Good day, folks. In this video, we're going to learn how to control the speed and direction of DC motor using microcontroller ATMega 328p and the motor driver. So a brief simulation. Here the motor goes to the clockwise direction, and this is the other side, the counterclockwise, and we can control the speed too. Now it's getting pretty slow and it's pretty fast. Yeah, that's it. So in this video there are gonna be three main sections. The first one is the idea of this, how this simulation work. Then the second is how to make this simulation, and then the third is the algorithm of the program and the syntax explanation. Okay, so let's break down this circuit. First one, we have this microcontroller ATMega 328p with the clock speed of 16 MHz. This is the base microprocessor for Arduino Uno, the famous one. Then we have this motor driver, this DC motor, and we have buttons to control the direction, and we have this potentiometer for controlling the speed of the DC motor. So if we see the characteristic of this DC motor and its relation with the driver, if we connect this to the power and the ground, see the power input to the input 1 and the ground input to the input 2, controlling the DC motor to move in the clockwise direction and vice versa. And if you see this is like laggy, a bit lag, it's because the hardware of the computer that I'm using. So it's like this. And then we have two main ports that we use here, the B port and the C port. In the C port we use it as the input port. The C port will read the input of the button and the potentiometer in the C ports, and then this B port, B1 and B2, will give some voltage output signal to this driver. And if we see, there is a special feature of the microcontroller that we are using here. We are utilizing this PWM or pulse width modulation feature that we have on the microcontroller. So a brief intro for PWM or pulse width modulation is a method for reducing the average power by electric signal by effectively chopping it up into discrete parts. This is the illustration. Like if you have a full 100% power, we're gonna chop it into small discrete parts, and the PWM characteristic or mechanism will feed the load by turning the switch between supply and load on and off at a fast rate. So the overall average power will be reduced. And there is a term of this duty cycle, describe the proportion of on time to the regular interval or period of time. So if we want to have 50% duty cycle, it means we're gonna have 50% of the time that the switch is on and 50% of the time that switch is off. And this will be moving in a fast rate, so that we hope we're not gonna notice the difference, and then the circuit or the program will run smoothly and as if it's reduced as the analog mechanism. That is, you can read a good explanation in this Wikipedia page. And then we have this analog to digital conversion mechanism. So we're gonna read this potentiometer value. We're gonna read the voltage or the voltage value that is distributed in this C2 pin, and the potentiometer will of course reduce the value of the voltage. And then there are some pull-ups and pulls-down mechanism. Means that the basic state of this C port is high, that is signed by this red color, and if we push the button it will be turned to low because it's connected to the ground. And this, except for this C2 pin, the basic state of the pin is low, and if we change the value of this potentiometer, it will be high. And I'm using this potentiometer inverted, means that if we turn it to 0, it will be fully connected to the ground, and if we turn the value to 100, it will be connected to the power. Yeah, so that's basically when the idea is when I turn this button on, and this C0 pin will be having a low value, and we will give this the first PWM pin or PB1 the signal or the high value output. Vice versa, if we press this button, we're gonna give the input the second PWM pin or the PB2 high output, sorry. And we're gonna change the speed. You can see there's the change of rate in this pin, because which will be changed by the value of the potentiometer, that is utilizing the ADC principle, right? That's enough for how the circuit works. And then let's move into the hands-on of the project making. So let's make the programming section. We're gonna make this using CodeVision AVR. Let's make file, new project. We're not gonna use the code wizard. And then let's save it in the document. PWM. We're using the ATMega 328p. This one with 16 megahertz clock speed, and yeah, that's it. And there's an optional to use this LCD function to give some good display, right? This is it. Just delete it first. And if you need some intro for making this circuit, I'll make it quick. Let's see. PWM. Oh, almost forgot. So in this simulation, we're gonna use two softwares. The first is Proteus 8 version and the CodeVision AVR. Yeah, this is the Proteus. We're gonna need ATMega 328p, and then we're gonna need DC motor, like obviously. I'm gonna need potentiometer, and we're gonna need the motor driver Okay. So. Oh yeah, we also need buttons. Yep. And maybe if we for additional we can use LCD. Or even better, I'm gonna add it later. So first we're gonna add some button here. Like here. Okay, it's good. Potentiometer here. Sometimes these labels are annoying. You could hide it. It's better. And yep, that's it. We're gonna connect this output 1 and output 2 to the DC motor, the input 1 and input 2 to the microcontroller, and this button 2. And yep, and then we're gonna need some power inputs. Okay, the enable one is connected to the power input, and this one, I think it's here. And then some, oh yeah, and here, the reference port. Okay, and the ground port here. All right. Okay, it took me about several minutes to build this. And then let's jump into the programming part. We're gonna use this pre-made program by me. Okay, so first we're gonna have to import some libraries. This is the microcontroller libraries. This is the library for delay function. This is the standard library of, I don't know, microcontroller maybe. Yeah, for like kind of C programming. And this library for LCD function. And then we have to state some global variables. I'm gonna state this ADC VRF type to 14 hex is the value of the reference voltage source, and I'm gonna define pin C0 to S button 1, pin C1 S button 2, and I'm gonna define some PWM variables. OCR1A high and low, it's H, and L means high and low, SCWM1 high, etc. And I have two additional functions here. First is the map function. If you're using Arduino for, if you have ever used Arduino, maybe you know this function. It's gonna change this input value from this range into this target range. It's like scale one value to another scale, the conversion from Fahrenheit to Celsius, like that kind of thing. And then this is the ADC function to initiate and to read the analog value from anywhere, from the ADC input, of course. And there is this main program. So the first, we have to declare the local variables. There are this nilai potensio, it's Indonesian. It means, let's replace it with potentio. Well, is the value of potentiometer. And there's a speed, and there is the character text of 16 characters. And we have to define the settings of port and pins. The C port is pulled up. So this C port is basically pulls up, set to the high value at default, and this pin C2 is pulled down. This one is pulled down, so we can read the voltage value from here. And then the DDR, we're gonna set this C port as an input, and for port B we're gonna pull it low as ground, and for the DDR-B we're gonna use it as the output for, you know, this port. Then the ADC control and status register, gonna enable this ADC SRA with the prescaler of 32-bit. If you're gonna use the 64-bit, you can use this value. And we're gonna turn this to low, means we turn this off. And we set the PWM mode as the fast PWM. And this, you know, this is some clock variables or timer variables set to 0. And we initiate this LCD function. And for the looping part, this logic is used if both of the button is pressed. Then we will set all the PWM function or speed function value as 0. So this motor won't move. Yeah, and then if we have the LCD, we're gonna print this motor speed as 0. And I think we're not gonna use this first, like, yeah, it's not so important though. Let's just delete it. We're not gonna use it anyway. Okay, so the second is if the first button is pressed, and then the pot file, and we will read the ADC value of the second ADC port, which is this. You see, this is ADC 0, 1, 2, 3. We're gonna use with this the second ADC pin and save it as pot value, and we're gonna change this speed value by using this map function. This is gonna be useful if you want to use this. So if you want to print this text, this speed to the LCD, you have to change the value, because the analog basic value is 0 to 120 10 bits, and you can use this to 100% scale or whatever. And we're gonna change this PWM2 values to 0. It means it will not enable this second button of PWM pin. Will be set to 0, but this one we're gonna set this potential value as an 8-bit hexadecimal value, so it's divided by 2, high and low. And so let's compile it. Okay, no error, and then build the project. Okay, done. Now we're gonna load the project from this Proteus. See, open the project folder and open this hex file. Okay, so let's start the simulation. Okay, so it's moving clockwise direction, it's moving vice versa, and let's change some speed. Okay, changing pretty slow, right? So that's it. That's how you control the speed of the DC motor using, you know, this microcontroller ATMega 328p. by utilizing PWM function and ADC function. And for additional, let's add some LCD monitor. So we're gonna take some. Oh, anyway, there is a function named project clip by this Proteus. So we could have this pre-made component. This one, I have this pre-made component of LCD that's connected to the terminals, but I think it's too messy. I'm gonna make another one. LCD 1622 alphanumeric. Let's just put it here. Okay. For the cables, there are several cables. So okay, let's connect this here. Shoot. Okay. This one connected to the 7th port. This 6, 5. For I hate messy things. Okay, I think for this D0 will be connected to D0, D1. Oh man. Oh, okay. It's out of control. Okay. Oh, it's better. I think it's not connected. D0, D1, D2. Okay, I think it's true. It's correct. Let's hope. No, it's not correct. Don't have the display part. Okay, so this one should be connected here, and this one to here, and this here. Let's see. Yep, I've got the display. So yeah, this is for like additional function, additional feature for this motor speed and direction control by using ATMega 328p. So yeah, I think that's it. That's the video, the tutorial. I hope this is useful for you. I'm sorry for my unclear explanation. If you want to know some more things, or if you have some questions about this topic, you could just contact me. Yeah, that's it. Thank you for watching.